Good morning all, this is Dr. T. Khalandar Basha, working as Associate Professor in Electronics and Communication Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. So today we are going to describe the signal description of 8255, which is PIO, where PIO stands for Programmable Input Output Device. So under the course, microprocessors and microcontrollers. The slides are prepared by referring the textbook Advanced Microprocessor and Peripherals by K.M. Budchendi and IARE, Tata McGraw-Hill Publications. So what is a peripheral device? So basically the input and output devices which are connected to microprocessor are known as peripherals. So these are like printers, floppy drives, CRT and cassette recorder, mouse, monitor, etc. So now we will see the classification of interfacing device. So peripheral devices can be classified into two categories. One is general purpose peripherals. The second one is special purpose peripherals. Now we will see what is a difference between these two, or what are the various general purpose and special purpose devices we are having. So generally we use those frequently to interface peripheral devices, which are Programmable Peripheral Interface (PPI), Programmable Interval Timer, Programmable Interrupt Controller, Programmable DMA device, and Programmable Communication Interface. So this Programmable Peripheral Interface, we can also call this one as Programmable Input-Output Device. Next, some special purpose peripheral interfacing devices for microprocessor. Those are used for a specific applications, type of I/O devices, such as Programmable Keyboard and Display Interface, Programmable Hard Disk Controller, and Programmable Floppy Disk Controller. These are the few examples for special purpose peripherals. Now we will see the need of 8255 as well as signal description of 8255. So the peripheral input output port chip, that is 8255, is also known as Programmable Peripheral Input Output Port. The Intel's 8255 is designed to use with 8 and 16-bit and higher order microprocessor. It is basically consist of 24 input-output lines like port A, port B, port C, which are of 8-bit ports, which may be individually programmed into two groups of 12 lines each or 3 groups of 8 lines each. That means the program whichever we are using, either we may use port A or port B or port C. All these are 8-bit ports. So if you are using for 8-bit applications, we have 3 ports, that is port A, port B, port C. If you are using for 12-bit applications, we have group A and group B ports, where we can use for a 12-bits port applications. Under group A, we have port A and port C upper. Under group B, we have port B and port C lower. Right. So these two group of I/O pins are named as group A and group B. Each of the two groups contain a subgroup of 8 I/O lines called as 8-bit port, and another subgroup of 4 input-output lines, that is 4-bit port. Thus, group A contains an 8-bit port A along with a port C upper, that is from PC4 to PC7. The port lines are identified by the symbols port A0 to port A7, which is 8-bit port, while the port C lines are identified as PC4 to PC7. Similarly, group B contain an 8-bit port B containing the lines port B0 to port B7, which is 8-bit port, and a 4-bit port C lower with a PC0 to PC3 that we are going to group as group. So the port C upper and port C lower can be used in combination of 8-bit port C. With the port C are assigned the same address. Thus, one may have either 3 8-bit IO ports or 2 8-bit and 4-bit IO ports. So all of these ports can be function independently either as input port or output port. So this can be achieved, that is a programming of a particular port either as a input port or output port can be achieved by programming the bits of internal register of 8255, which will call as control word register. Now the figure shows the pin configuration of 8255 where it is a 440 pin chip. Now we will see the pin configuration in detail. So the signal description of 8255 are briefly presented as follows. So first we have port A0 to port A7. So if you observe the port pins, that is 1, 2, 3, 4, as well as the port pins 37, 38, 39, 40. So these 8 pins are corresponding to port A, naming from port A0 to port A7. So these are 8 port A lines that act as either latched output or buffered input lines, depending upon the control word loaded into the control register. Control word register. So whenever the control word register corresponding to port A, if you configure that as 1, then that particular port is configured as input port. In the control word register, for port A corresponding bit, if you are given as 0, then it will be configured as output port. Next, port C7 to port C4, these are the pins from 10, 11, 12, 13, 14, 15, 16, 17, all are corresponding to port A. Now we will see the pins from 10 to 13, which are port C7 to port C4. These are upper nibble of port C lines. These may act as either output latches or input buffer lines. So this port can be used for a generation of handshake signals in mode 0 and mode 2. 8255 total we can use as mode 0, mode 1 and mode 2, where in mode 1 and mode 2 handshake signals are required, whereas mode 0 the port C will act as the data transfer port. Now coming to the lower port of port C, that is PC3 to PC0, these are lower ports of port C lines. These may act as either output latches or input lines, same as that of upper port C bits. These ports can be used for generation of handshake signals in mode 1 and mode 2. Next we will see next inputs. PC7 to PP7 to PP0, that is port lines from pin number 18, 19, 20, next 21, 22, 23, 24, 25. So these are the pins corresponding to port B. These are 8 port B lines, which is used as latched output lines and buffered input lines in the same way as of port A. Here also for configuring port B, if we are configured this particular bit in the control word register as 1, then the port B will act as input port. If the PB bit in the control word register is reset or configured as 0, then the port B will act as output port. Next is RD bar, where RD bar, that is pin number 5, which is a status signal indicating this is the input line driven by the microprocessor and should be low to indicate the read operation to 8255. So here the 8086 processor is interfaced to 8255. The read signal of 8086 processor is connected to the read signal of 8255. So this read signal is a output with respect to 8086, whereas the read signal is a input for 8255. So whenever this goes to low, because it is a act to low signal, so whenever this signal is 0, it indicates the processor is reading the data. Either it may be reading the data from any one of the port, either port A or port B or port C. Next we have a write bar. This write bar also connected from microprocessor to 8255, which is a act to low signal, and this write bar is a output signal for 8086, whereas it is input for 825. So write bar, this is an input line driven by the microprocessor. A low on this line indicates write operation. So whenever this write bar is equivalent to 0, it indicates the processor is writing some data to 8255. Either it may be configuring the data for control word register, or it may be writing the data to the IO devices which are connected to port A or port B or port C. Next we have chip select line. The chip select line is a act to low signal. So whenever this chip select line is act to low, it enables 8255 to respond to read signals and write signals. Otherwise, the read signals and write signals will be neglected. So if CS bar is equivalent to 1, even though the data is writing on the data bus and read and write signals are enabled, so no action will be performed by 8255 as it is in the disabled state. So we can consider CS bar is equivalent to 1, we can consider this one as a disabled state of 8255. If CS bar is equivalent to 0, then we can consider this one as a active or enabled 8255. So that we can have the data exchange with the IO device. The next one corresponding to the address lines, that is A1 and A0. So these A1 and A0 of 8086 are connected to 8255. A1, A0, here also A1, A0. Sometimes this will be changes to A1, A2 also, we will see that. So A1, A0, these are the address lines are driven by the microprocessor. These lines A1, A0 with RD bar and write bar and chip select forms the following operations of 8255. So when read bar is equivalent to 0, it indicates the processor is reading some data. So when reading operation is performing, so write should not be enabled. So the write bar should be equivalent to 1. So here only read operation is active. Next, as chip select is low, the data transactions can be takes place. If A0, A1 are 0, 0, we are having the read operation with respect to port A, 0, 1 port B, 1, 0 port C, 1, 1 control word register to data bus. Next, write operation. So in that case, the write signal will be active by making write bar is equivalent to 0. When we are performing write operation, read should be inactive. So we will write RD bar is equivalent to 1 case. As we need to perform the data transactions with 8255, chip select should be enabled. Then depending upon the values of A0 and A1, the data may be writing to the data with respect to control word register, port A, port B, port C. So 0, 0, it is for port A. 0, 1, which operation it is performing? Write operation to port A. 0, 1, write operation to port B. 1, 0 operation, write operation to port C. 1B corresponding to control word register writing. Let us consider if CS bar is equivalent to 1. When read signals are either it may be 0 or 1, don't case we are going to be considered. Because the chip select is inactive, whatever the information we have on A0, A1 as well as write and read, nothing will be considered. So the data bus will be tri-state. So what is this tri-state means? From 8086 processor to 8255, the data bus is connected physically but logically isolated. This is a data bus. So tri-state means the connection physically exists but logically data transfer will not be takes place. Next, when chip select is active but no read operation or no write operation, whatever be the A0, A1 lines, they are don't case. Then also we can consider the bus is tri-stated because the data transfer is not taking place as read and write signals are inactive. Next, so whatever the address lines which are considered A0, A1, these address lines are used for addressing any one of the 4 registers, that is 3 ports, port A, port B, port C and control word register as we have shown in the previous steps. So in case of 8086 system, if the 8255 is interfaced to the lower order data bus, the A0, A1 pins of 8255 are connected to A1, A2 of the 8086 respectively. Next we have the data lines, that is D0 to D7, that is pin number 27 to 34. So these lines are data bus lines. Those carry data or control word register to or from the microprocessor. So from 8086 processor to 8255, the data will be transferred on the data bus. So here the data bus size is 8 bits. 8086 processor is having a 16 address data bus, out of which we are going to use only 8 bits, that is D0 to D7. Next we have the reset pin. So the reset pin, it is a logic high. On this line, it clears the control word register of 8255 and all the ports are set as input ports by default after reset. So these are the various signals we are having. So the various pins which we are discussed is port A pins. Next, write bar and read bar, read and write operation indicator to enable chip select, data lines D0 to D7, port B lines 25 to 18 to 25. Next, port C lines, that is from pin number 10 to 17, A1, A0 for address lines, and these are the 2 supply lines we are having. One is VCC and the one is ground. Now we will see how typical interfacing system of a 8255 with 8086 processor. So now the microprocessor, whenever it wants to communicate with the input device or output device, directly these input devices we don't have connecting facility to 8086 processor. So in between that, we are going to be place the 8255, which is a programmable peripheral interface or programmable input output device, where from the microprocessor to the PPI or PIO, we have address lines, data bus and some control signals. Here the control signals are like write bar and read bar signals. Next, as we know in 8255, we have port A, port B and port C. The IO devices we can connect to any one of these ports, either port A or port B or port C, depending upon the mode of transaction, that is either the device you are taking as input device or output device. The port bits which are present in the control word registers are configured. Whenever we write a particular port bit in the control word register as 1, then that particular port will be configured as input. If you written as 0, it will be configured as output. So in this session, we have discussed what is a peripheral device, classification of the peripheral devices. Next, 8255, the signal description along with the pin diagram pin of 8255. At the end, just we given a glance of how 8255 and 8086 will be communicated. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.